The first lesson in this module is named algorithms and steps in problem resolution. We will talk then about the tasks workflow, analysis and decomposition, and then we will see our first algorithms. So remember that the objective of the course is to find and develop a computing solution for a given problem. What happens most of the time, students, because are in the context of programming and computer science, they directly dive into switching on the computer and start programming. This is not the right solution when you have a problem in hand. Please remember that first of all, take time to do two very important steps when you have a problem in hand and you would like to find a computing solution. Think about the problem. Don't dive into your computer at the very first time, and sketch a tasks workflow. What is this tasks workflow? It is steps, a sequence, a workflow, or a pipeline of different tasks that are pipelined one after the other. So the first step to start with, previously mentioned, is to analyze the problem. Think about your problem first of all, then decompose it, find a corresponding algorithm. These three tasks are put within what we call the logic of programming. It's not yet the programming step, but it's the logic of programming. Then we jump to the next big step, which is coding or programming, finally validating the whole program. These two steps are put within the programming side. As you can see, the workflow is decomposed into 5 steps. These 5 steps are 3 of them concern the logic of programming and 2 of them concern the programming side. Let's start with the analysis and decomposition now, which are the 2 first steps or tasks. Analyze a problem. What does mean analyzing a problem? This is the most important step, because if you don't understand your problem, you cannot find a solution for this problem. You cannot fix it. So first of all, think about the solution, because when it is well done, it eases the following step or all the following steps. What does mean analyzing? It's the task of searching a resolution method, especially when the program or the algorithm or the problem in hand is very complex. Then what does mean decomposing? In order to overcome the complexity of the whole problem, you cannot start from the beginning and writing all your tasks in one shot. You should decompose from what to what. We proceed by progressive decomposition and we break down from the general to the details. Let me give you an example. All of you have already used Microsoft Word or Microsoft PowerPoint. Think that this kind of software were not very easy to program from the very beginning. So for instance, one team was responsible of developing all what concerns the management of files, to open a file, to save a file, to print a file. Another team is responsible of, for instance, spell checking the errors, editing with colors, putting the bold, putting the italic. One other team maybe is responsible of the reviewing of the text. So you can see that the problem is so big, so complex, that it was necessary from the very beginning, from the team that was responsible of developing the solution of Microsoft Word. They were obliged, it was mandatory to decompose it from the very general to the details. The same logic holds for all the kinds of software we already know, like ChatGPT, like Google search engine, so on and so forth. So it is important, as I previously mentioned, to analyze, think about the problem, what is the problem in hand, and decompose it. Good. The next step is to find the algorithm. Maybe we talked about the algorithm a little bit in the previous module, but now let's go into the details. So an algorithm, it is a sort of standard code. Now that you have decomposed all your problem in hand and you have very small details, you can start writing the logic of the programming. So an algorithm is a standard code that is ready to be translated to any programming language. It is a logic sequence of steps to follow to solve a problem. It comes as a sequence of different steps starting from first statement, second statement, etc., until you reach the final statement. So all these statements constitute a simple algorithm. Of course, the whole problem may be different algorithms and each one of them solving a specific sub-problem. In terms of definition, an algorithm is then a fixed number of statements, of instructions, of orders to give to the computer. So these statements, they are executed in a known sequence and applied to a fixed number of data, and that is computer and language independent. We have just said that it is a standard code, so any computer scientist all over the world, when reading an algorithm, is able to translate it to the programming language of his preference. So if he is familiar with C, it might be very easy for him or her to translate the algorithm from the algorithm standard code to C, or from the algorithm to Python, or from the algorithm to Java. It is a standard code that all computer scientists all over the world need to understand and know by heart. So it is a duty for you to know the algorithms by hand, because this is the first thing every computer scientist need to know. So I have just mentioned it is a sequence of statements. Let's take an example that we have already taken in the past. So reading a variable is a first statement. Reading a second variable named y is a second statement. Then computing the sum is the third statement. And finally displaying to the monitor is the fourth statement. So this is an algorithm containing 4 statements and consisting of solving a very basic problem, of course, which is in our case here simply computing the sum of 2 variables. Let's take other examples to see what are the kind of algorithm. So suppose we are in the case of gardening, right? And suppose we know only 4 basic actions. So suppose we know how to dig a hole, how to plant a tree, how to close the hole, and then how to water the tree with some water. Now, suppose that we have a robot and we want this robot, we would like to find an algorithm for this robot to do something. What is the algorithm, the problem in hand? Only planting a tree. So knowing these 4 actions, the algorithm will consist in combining 1, 2, 3 or some of the actions available to find the solution of our problem. So here it's very basic. We simply dig a hole as a first statement, we plant a tree as a second statement, and finally we close the hole as the third statement. Let's increase the complexity. Now we are not going to plant 1 tree, but we would like to plant and watering multiple trees. So what will be the algorithm? We're going to dig a hole as we did previously, we're going to plant a tree, then we're going to close the hole. After this, we should see, do I have other trees in hand or not? Am I done? If I have other trees, I will jump again to the first statement and dig a hole, plant one of the remaining trees, close the hole, and again check. Do I have other trees? I will repeat this part until I have no more tree. In this case, what I will do, I will execute the next statements, and the next statement will consist of watering all the planted trees. So this is one example of an algorithm. As you can see, it is a logical sequence of statements executed in a known order. So I start from 1, 2, 3, and here I order the machine to go back to statement 1. So you can see that I know the sequence, I master the sequence of the execution of this algorithm. If you think about it a little bit, you would see that I can very simply change. You might have asked yourself, why water all the trees at the end? I can simply, after closing the hole, I can water the tree. Yes, it's possible. I do agree with you. I can, in this case, the algorithm becomes, I dig a hole, I plant a tree, I close the hole, and then I water the tree. And then I check, do I have other trees? If yes, I will execute the statements now from 1 to 5. So you can see that I have what? 2 algorithms for the same problem. So remember, please, very important, for any given problem, as computer scientists, you might have many algorithms. One algorithm might be different from the other, not in the objective, but in the efficiency. Maybe one algorithm might be quicker, might take less time, might be less demanding in terms of data, etc. As a summary for today's video, please don't forget that it is important not to dive at the very beginning to start coding. Analyze your problem before coding by decomposing from the general to the details. And we have just said that multiple algorithms might be the solution of your problem, and later on we will consider which one is the most efficient.